Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode problem number 2441, largest positive integer that exists with its negative. Given an integer array nums that does not contain any zeros. First condition, find the largest positive integer k such that minus k also exists in the array. We are asking us to find a k in that array which is largest among all values, and for that same k I want to have minus k, right? Return the positive integer k. If there is no such integer, return -1, right? So take this first example. What is the first example? It is -1 2 -3 3 -1 2 -3 3. Here what is the greatest element? It is 3. Whether -3 is present, yes, then the output will be 3. This is my first example. Okay, fine. Now check over the second example. -1 10 6 7 -7 1. -1 10 6 7 -7 1. Right. Now in this example, which element is the greatest element? It is 10. It is 10. But there exists -10. No. Fine. Now, which is the second largest element? Which is the second largest element? That is 7. Whether there is -7? Yes. Then the output will be 7. Right? Now, coming to the third example. -10 8 6 7. -10 8 6 7. -2 3. -2 -3. Now, which element is the largest element? It is 8. Whether there is -8? No. Okay. Which is the second largest? It is 7. Whether there is a minus element? No. Which is the largest element? Again, it is 6. Whether there is -6? No. There is no element which is positive and which is negative, right, in that array. So the output will be -1, right? So this is what the question states. Now, how to approach this problem? How to approach this problem? Okay, fine. If we can find the element which have both positive and negative values in this array, then that should be my part of my answer. Then that is part of my answer, right? Then take for example, -1 1, -2 2, -3 3. There exists -1 1, -2 2, and -3 3. But which should be my result? This is my result. My result will be 3. So after finding this all combos, can I get the maximum value? Can I get the maximum value? This is my brute force. This is my brute force approach. Then how to execute this? I can traverse from 1 by 1 element in this array. And I take the minus value and check whether same plus value is in this array. First I take this -1, whether there is +1. I go and check from here, and next element, then next element in total arrays. Okay, in the total elements in that array. Yes. For -1, there is 1. Now update my result as 1. Right. Now again I go for elements which is minus value. Again -2. Then I check whether plus 2 is present. So this is not +2. This is not +2. This is +2. This is +2. Now I have -2 and +2. Whether +2 is greater than +1? Yes. Then update my result with 2. Right? Now I am going to check for any other negative values. There's another negative value, -3. Okay. Whether it is +3? No. 3. Yes. Here exists 3. Here exists 3. So direct is minus 3 and 3. So I update this 2 as 3 because 3 is the maximum value. This is my brute force approach. So for this brute force approach, I take a for loop for I and run from 0 to n. Inside that, I use j that runs 0 to n. But the condition is the array of I should be less than 0. That is, it should be negative value. Negative value. And if I find a of j equal to absolute value of a of I, absolute value of a of I, then I can update the result with max of result and the value of a of j. Initially, I want to put my result at minus 1. Then at last, I have to return the result. Return the result, right? This is my brute force approach. So coming to the time complexity, what is my time complexity? It is O of n square and space complexity is O of 1, right? Can we optimize it? Okay, let us carefully see this. For this negative values, I want a positive value. It may be anywhere in the array. So can I take a searching data structure? So can I take set? Can I take hash set? Right? The finding time complexity in hash set is O of log n. Right? So can I reduce the time? Let us see. First of all, I push every values inside the set. Take for example, let us take arrays minus 1, 1, minus 2, 2, minus 3 and 3. I will push everything into this set. So this is my set. And this is my array. Now I'm going to traverse in this array. Such that if there exists any minus value, I check in this set whether there exists a positive value. Right? So here exists a minus value, minus 1. Whether there is plus 1 in the set, it is a searching technique which take O of log n. So there exists plus 1. So update 1 because maximum of minus 1. Initially result is minus 1. Maximum of minus 1 and 1 is 1. Now go to the second value. It is not minus 1. Sorry, it is not minus value. Then it is a minus value. This is a minus value. There exists any 2 in set? Yes. Then update. It is 2. Now go to the next value. Whether this 2 is minus value? No. Whether this minus 3 is minus value? Yes. Take this. Whether there exists 3? Yes. Update this 3. Right? Whether this 3 is a minus value? No. Then goes and terminates. Now the result will be 3. So talking about time complexity and space complexity, time complexity will be O of n log n, and space complexity will be O of n because of the set data structure. Can we use any alternate method? Yes. Shall we use two pointer? Because we know that always the negative values will be at the left and always the positive values will be at right when they are in sorted order. Right? See here, for the array minus 1, 1, 2, minus 2, 3, minus 3, when I sorted this array, the array will be changed into minus 3, minus 2, minus 1, 1, 2, 3, right? Now see this point and also see this point, whether they are same. Yes, yes. So I want maximum values. The maximum values will be at the right side, and I can alternately check whether the left values are the negative of the maximum values or the negative of the maximum values. Right. Now take an example, and I will explain it clearly, this approach. Let me take this example. -1, 10. Right. Now, what is my approach? I want to first sort the elements. Just sort -7, then -1, 1, 6, 7, and 10. 10. Right. Now I have to point this pointer here and another pointer here. Whether 10 and -7 are equal. That is, absolute value of -7 is equal to 10. No. Then which pointer I have to move towards another pointer? Maybe if I move towards this side, I can get a lower value than 10. That maybe 7. So I can move this pointer here. Now 7. Whether absolute of -7 is equal to 7. Yes. Then return 7, because this is the maximum value among this everything in the left. So why should I go for this all leftmost element, and I have to check. Okay, understand? This is why we start from this rightmost element and string towards left, and once we have found, we just return. If we don't found, just return -1 after the loop exits. Okay, when the loop terminates, when this pointer and this pointer lies at the same position, at the same index, the loop gets terminated. Or maybe here, but this front pointer is exceeding the rear pointer, then I want to stop the loop. Fine, this is my approach. Let me show the code. See here, this is my starting brute force approach, right? First I am storing length in n, then result is equal to -1 for I in range of n if nums of I is less than 0. That is, if the nums of I is a negative number, then I have to iterate to every elements and check whether absolute value of I is equal to nums of j. Right? If that's so, I can store the maximum of result and nums of j in result variable, then return the result. Fine. Then coming to this set method. Coming to a set method, I have declared s is equal to set of nums. M is equal to -1 for I in nums if I is less than 0 and apps of I in s. If I is less than 0 and apps of I in s. If the current element is negative as well as its positive value is in set, then I have to update the maximum. Right? Then return the maximum. Inside this yes, there will be set of nums. The nums will be stored as a set. Fine. This is my second approach. Then final approach is two-pointer approach, which time complexity is O of n log n and space complexity is O of n because of the let's sort. Here I am sorted. Then while L is less than R, if nums of L is greater than or equal to 0, return -1. Why I am doing this? Because let us assume an array. Let us assume an array -1, 2, 3, 4. Otherwise, minus 5, minus 5, minus 5. Now here is my pointer. Here is another pointer. Whether minus 5 is same as this 4, because absolute value of 5 is 5. 5 is not equal to 4, right? Right. So I have to move this pointer here, this pointer here. Maybe minus 4 can be other right side. So I can move here. Now whether I have a negative value here, I want one negative value and one positive value which are equal. But here there is no negative value. Then how come I get a result? So that I will return minus 1. Understand? Now one case is finished. Now start is equal to apps of nums of L. If start is equal to nums of R, return nums of R. Else if start is less than nums of R, return R minus is equal to 1. We are shrinking that R. By decreasing 1. Fine. Else L plus is equal to 1. Return minus 1. Fine. So this is what my approach states. This approach. Right? Let me run this code. Fine. This is submitted successfully. So this is the approach for this question. Thank you.